Okay, so what we're going to do is uh, we're going to look at a quadratic function that's written in standard form, and then we're going to take this quadratic function, we're going to rewrite it in the vertex form, and then we're going to use the vertex form to sketch the graph of the function. Okay, so let's go ahead and start off with this function. We have f of x is equal to negative 3 x squared plus 24x minus 46. Okay. So what we want to do is we want to first rewrite this in the vertex form. Anyway, the vertex form. Um, so now what we need to do, remember, we're going to only work with the first two terms of this quadratic function. So we need, or the process in which we're going to use, the process that we're going to use to write this in the vertex form is to complete the square. And so whenever we try to complete the square, we need the coefficient of the x squared term, or the coefficient of the squared term, to be 1. In this case, it's negative 3. So what we need to do is factor out negative 3 from both of these two terms. So we factor out negative 3, so we get negative 3 times x squared minus 8x. And then on the outside, it's still a minus 46. Okay. So now we want to complete the square on the inside of this parentheses here. So we're going to take half of the x term, a coefficient of x, and so in this case we're going to have negative 8 over 2, square that, and then that's going to be equal to negative 4 squared, which is going to be 16. Alright, so what we do with this thing now is we're going to add it and subtract it inside the parentheses, so we get this is equal to negative 3 times x squared minus 8x plus 16 minus 16 minus 46. All right. Now, we want, remember, the first three terms now of this, of the inside of the parentheses here, these first three terms, that's my perfect square. The negative 16 on the back end I don't want in there because, well, I want a perfect square, and right now I don't. So what I need to do is I need to take it out, but first I need to multiply it by the negative 3. So I need to distribute this negative 3 to that term. Remember, the concept behind this is that the negative 3 is supposed to be multiplying every single term inside the set of the parentheses. And if I just removed it, then it wouldn't be correct because I need to first multiply by negative 3 in order to take it out. So we multiply by negative 3 first, and so then we'll be left with negative 3 times x squared plus 8x plus 16. I multiply negative 3 and negative 16, that's going to be positive 48 minus 46. Okay, now factoring here, now this is a perfect square, so oops, this should have been a minus. Let me fix that really quick. This should have been a minus 8x. Okay. So x squared minus 8x plus 16. Okay, so now it's going to be negative 3. I need to factor the inside of the parentheses. That becomes x minus 4 squared, and then combining the two constants on the back end, we get plus 2. Okay, so now our quadratic function is in the vertex form. Remember the vertex form, we're comparing this to f of x equals a times x minus h squared plus k. The reason why we call it the vertex form is because hk, those are the coordinates of our vertex. Alright? Okay, so now that it's in the vertex form, now what I want to do is graph. So let's suppose I want to graph this. Okay. So what I do is I take my vertex, so the vertex in this case is going to be 4, 2. I plot that. So 4, 2, let's see, 1, 2, 3, 4, 1, 2. Okay, so here's 4, 2. Alright, next, let's see, all I need to do is find another point here, and one point we can find, also we know is that it opens upside down. Remember the a term here is negative, so I know it opens upside down, so I know it's going to go down. And so we're going to have two x-intercepts somewhere. I guess we can go with the y-intercept, but it seems like the easiest thing to do. So if I look at the y-intercept in this case, y-intercept well, that's going to be f of 0. And in this case, if I look at the original polynomial, if I subbed in 0 into the original, f of 0 would be negative 46 because the first two terms would be 0. And so that's going to be equal to negative 46. So now, with that in mind, keep this in mind. Remember what we did in class. Here's my table. I really only need 3 points because I have my vertex, which is 4, 2. I have the y-intercept, which is 0, negative 46. And if you remembered, another thing that we can use is the axis of symmetry. And I know that since the y-intercept is the x value, which is 0, for the y-intercept is 0, since that is 4 units away from this x value, 4, then I know that another value 4 units away, let's say to the, I guess it would be to the right of 4, which will say 8, is also going to have a y coordinate, or y value, a y coordinate of negative 46. Alright? And that's just going off the axis of symmetry. Since 0 is 4 units away from 4, and since 8 is 4 units away from 4, then both of these are going to have the same value. And so this is not to scale, but let's say this is negative 46 here. Then I know that at 0 I have a y-intercept here. And then at, let's say, 5, 6, 7, 8, that's also going to have a y of negative 46, something like that. And so I know my parabola is going to look something like this. Make sure it's a little rounded here. It's going to come down like that. Okay. So that's how we can graph the parabola.